What we're doing in this example is considering the sequence of equations involving Fibonacci numbers. And what we want to do, we have 1, 2, 3, 4 Fibonacci numbers, and we want to figure out, well, what's the fifth equation in this particular sequence of Fibonacci numbers? Well, in order to do this, what we want to do is we want to be able to figure out, well, what are the constants? What are the things that are the same? What are the things that are different? You know, we have 3 times 2 minus 5 equals 1. 3 times 3 minus 8 equals 1. What are the things that are exactly the same in each one of these 4 equations? If you look here, each one of these equations has a 3. That means in our fifth equation, it is going to have a 3. You know, in each one of these equations, there's, a set of parentheses. But inside the parentheses, the numbers are different. So what we're going to have to do is we're going to have to identify, well, what's going on here? Is there a pattern? You know, the next thing is everything has a subtraction sign. There's a number here, but they're all different, so they're not the same. We have to figure out what the pattern is. And then it's followed by an equal sign and then another set of numbers which are changing that we'll have to identify the pattern. Now I think this one over here to the right is the most easy pattern to identify if we are looking at the set of equations vertically. You know, there's a set of relationships vertically, but there's also a set of relationships horizontally between each equation. But for right now, I'm going to look at the vertical. If you look here at 1, 1, 2, 3, those are the same identical numbers of the Fibonacci sequence. So 1, 1, 2, 3, the next number would be 5. So if we're going to follow the pattern, that would equal 5. If we look here, 5, 8, 13, 21. Well, 5, 8, 13, 21. The next number in the sequence should be 34. You know, and then this one, 2, 3, 5, 8. 2, 3, 5, 8. Well, it should be 13. Now let's go ahead and see if this is actually correct. Well, what is 3 times 13? Well, that's, 39 minus 34. Is that 5? Well, yes, 39 minus 5 is 5. 5 equals 5. So that means that this fifth equation is correct. Now, the next thing we're going to have to do is, instead of just talking about numbers, we're going to start looking at this set of equations symbolically. Because what we need to do is, in the next problem, is we need to find the subscript that will make this equation true. This equation is related to all 5 of these, but now we're using subscript. So in order to find the relationship to be able to fill in this subscript right here, we need to transpose all these numbers into subscript. And if you see, I'm just going to take this away for a minute. 3 times 2. Well, 2 is the third Fibonacci number, so that's why there's a f sub 3 there. Minus 5. Well, 5 is the 1, 2, 3, 4, 5. It's the fifth Fibonacci number, equals 1. Now, 1, there's 2 1s, so this can be f sub 1 or f sub 2. We don't know, so I'm just going to put them both. I'm going to go to the next equation. 3 times 3. Well, 3 is the 1, 2, 3, 4th Fibonacci number. So that's why that goes there. Minus 8. 8 is the 1, 2, 3, 4, 5, 6 Fibonacci number. Okay, equals 1. Well, 1 again could either be f sub 1 or f sub 2. I don't know. I'm going to put them both. Then we go to the next one. 3 times 5. Well, 5 is the 1, 2, 3, 4. It's the fifth Fibonacci number. That's why it's there. Minus 13, which is the seventh Fibonacci number, equals 2. Well, 2 is the third Fibonacci number. And then we'll go on to the next one. 3 times 8. 8 is the sixth Fibonacci number, minus 21, which so happens to be the eighth Fibonacci number, minus 3. Well, 3 is the fourth Fibonacci number. Let's go ahead and fill in these symbols for this last equation we just filled out. So we have 3 times 13. Well, what is 13? Well, 13 is the seventh Fibonacci number, minus 34. Well, 34 is the ninth Fibonacci number, equals 5. And 5 is the fifth Fibonacci number. So if we look at these vertically, we can start to see a pattern. F sub 3, F sub 4, F sub 5, F sub 6, F sub 7. You know, the same here. If we look here, now I think we can figure out what was this F, these ones, if that was the first or the second. So let's look F sub 5, F sub 4, F sub 3. You know, it's obvious now that this is F sub 2, which would make this F sub 1. So it's obvious that we see the vertical pattern here. However, in this example, we don't have any other. We're talking about the 15th and the 19th term. So we don't have, you know, 19 or I guess we need 15 equations. We don't have 15 equations. So what we have to do is we have to try to find the horizontal relationship. What's happening with these particular numbers? If we look here, we see that you know, this term and the third term, they are separated by how many terms? F sub 5 and 3, that's 1, 2. This is 2 terms before, you know. So that relationship, let's see if that's true for these two. Yes, the 6th and the 4th term. Those are 1, 2 terms before. The 7th and the 5th, 1, 2 terms before. The 8th and the 6th, 1, 2 terms before. The 9th and the 7th, 2 terms before. So that's same going to be true about F sub 19. If I have F sub 19, 2 terms before would be F sub 18 and then F sub 17. So the symbolic notation that would go here would be F sub 17. And if we look at this other example, now we're just going to talk about total generic symbols. And we're going to take this a step further. 3 times F sub n plus 6 minus F sub n plus 8 equals F sub, we got to figure out this subscript. Well, let's go back to our symbolic notation that we were referring to in some of the problems previous. You know, well, we were just talking about in the last example how these two terms are related. This term is 2 terms before this. You know, the F of 7 is 2 terms before 9. 8 is 2 terms. 6 is 2 terms before 8, and so on. So the same should be true here. F sub n plus 6 should be 2 terms before F sub n plus 8. And if we look here, we have F sub n plus 8 here. 2 terms before would be F sub n plus 7 and then F sub n plus 6. So yes, this is 1, 2 terms before. So yes, that relationship holds true. Now we have to figure out, well, what is the relationship here? Well, if we look at 9 and F sub 9 and F sub 5, or F sub 8 and F sub 4, back in our previous problem, what is the relationship between these two? Well, F sub 9 and F sub 5, that is 1, 2, 3, 4 terms before. Well, is that same with F sub 8 and F sub 4? Let's start with F sub 8. We have 1, 2, 3, 4 terms, and we get F sub 4. Let's try it with F sub 7. You know, if we go 1, 2, 3, 4, that gives us S sub 3. So what that tells us is that these two, this number is 4 terms before this number. And so that relationship should hold true in this particular example. So if we have F sub n plus 8, this number should be 4 terms before F sub n plus 8. So if this is F sub n plus 8, 4 terms before would be 1, 2, 3, 4, which would give us F sub n plus 4. You know, just to check ourselves, let's make sure that the relationship between these two numbers is intact. Well, let's go back here. What's the relationship between F sub 7 and F5? Well, if we go back here, F sub 7 and F sub 5, that is 1, 2 terms before F sub 7. So that's 2 terms before. Well, is that true for each one of these equations? Is if we have F sub 6 Is f sub 4 two terms before? 1, 2. Yes, it is. Let's try this one. If we have f sub 5, is f sub 3 two terms before? 1, 2. Yes, it is. So the same should be true with our generic equation. If we have f sub n plus 6, which would be right here, f sub n plus 4 should be two terms before f sub n plus 6. And if we look, 1, 2, yes, we get f sub n plus 4, so we know that the generic symbolic notation here is correct.